Okay, my friends, so the tool you need is in our Excel calculator. It's a relatively new tab I just added. We're going to crack this thing open. And we were just spending time in the binomial distribution. We're going to come over here to the normal distribution now. If you get that enable content thing, go ahead and definitely select it. Now, it's going to look a little bit crazy at first because this sheet that I built can do two different things. In this case, you actually have z-scores of negative 2/3 and 2/3 because we're going from negative 2/3 of a standard deviation to 2/3 of a standard deviation. When you have the z-scores like that, you're going to want to use this top half of the sheet. Okay, we'll look at the bottom half in the next video. So all you've got to do is put your z-scores in this spot right here. So for example, 2/3. Now, just another warning about this. I think we've talked about it before. Excel doesn't like fractions. So whenever I type a fraction, I just equals 2 divided by 3, and then it fills it up with decimals. And then the other one is negative equals negative 2 divided by 3. Boom. And then you have to select, what do you want? Do you want it below the z-score you put here? Do you want it between the two z-scores you put here, or do you want it above the z-score you put here? And you want it between. And it tells you that there is 50% of the area between those two z-scores. You can see the graph shaded right here. I tried to do that to you because I wanted to make sure you had a good visual of it. So you now know that half the population have IQ scores that are considered average by this IQ scale. Pretty rad. What I want to do now is go back to those IQ scale words, below, above, average, things like that, and just get used to using this sheet so you know how to put things into it. Sometimes you're going to use 2 z-scores, sometimes you only need to use 1, and I kind of want to get you used to it. So let's go back to the chart and look at another one. All right, let's just use moderately above average as an example, okay? Moderately above average. Okay, we're back at the board for a second because you may have noticed that I just gave you what are called raw scores. The 120 and the 130 are the scores on the IQ test. Any normally distributed data is going to have numbers that are scored in its own way, whether it's the diameter of trees, IQ scores, weights of babies. My spreadsheet, I didn't want to have it to write a spreadsheet for every different example, so I just talked about it in terms of pure standard deviations. So we have to turn those numbers into what are called z-scores, which are simply just measures of standard deviations. So I'm going to draw a real quick bell curve for us to chat with real quick. Don't worry about it not being perfect, because the spreadsheet takes care of perfect. 100, 1 standard deviation up is 115. 2 standard deviations up is 130. Hey, that's kind of convenient. We know that one already. That's one of the ones we need. We got to go 120 to 130. Well, if we know these are the raw scores, we need the z-scores. Well, these are 0, 1, and 2 for standard deviations. Eventually, we'll get ones that are negative 2. Those are kind of fun. 0, 1, and 2. Well, one of the z-scores we need is 2, because we need 130, right? Absolutely. But we also need 120, and 120 kind of nestles in here. I'll make it there. So how many standard deviations up is 120? Well, let's start at the average, because I think that makes the most sense. Start at 100, or 0, and go up a standard deviation. So it's clearly more than 1. But 1 what? Well, think about it. 120 is 5 past 115. That's a third of the way to the next standard deviation, isn't it? So that means the z-score here is going to be 1.33333 repeating. 4/3 if you like a fraction instead. So we have our 2 z-scores. One of them is 1.33 standard deviations, and one of them is 2 standard deviations. Let's go back to the calculator and figure out what that area is. All right, we're back here. We're still in the top part of the sheet because we still have z-scores. One of the z-scores we need, what do we say, it was 4/3 or 1.33. I'm just going to put that in there. And the top one we need is 2. And that area right there might look familiar. It's the one we just had drawn on the board. And as promised, it's a better picture because we have a computer generating the graph for us. Yay! That tells us that 7% of the population has an IQ that is defined as moderately above average. Let's do another one. All right, right, let's pick one down this side. Let's do a below average, the 80 to 90. Okay, friends, back at the board again. I want to drive home the transition between raw scores and standard deviations, because this curve is all about standard deviations. I mean, when we learned the empirical rule 1, 2, and 3 back in the day, it was all for bell-shaped data. It was all kind of bringing us to this point. So you have to get the standard deviations on the curve. So let's start with a curve. Please excuse the crudity of this model. I didn't have time to build a scale or to paint it. And the average. We're going to slap the average there in the middle. There's your 100. Now, standard deviations, out 15. Now, this is below average, so we're going to be going to the left of average. So we'll start by going down to 85, then we'll go down to 70, and I forget how far we're going. We're not going past 80, so that's far enough. Now, z-score-wise, use z-scores in green again. These are the raw scores. And these are the z-scores. Average is 0. If you're going down from average, you have to be negative. So that's -1 standard deviation. That's the minus in the plus or minus. And this is going to be -2. So below average is definitely not as far down as 2 standard deviations below. But where is it? Well, we got to go 80 to 90. Well, 80 is going to be here, and 90 is going to be here. I think I used color last time. Yeah, I used orange last time. Let's draw that in. That 90 is not quite in the right place. There's 90, and there's 80. That's the area we're looking for. And again, the computer's going to give us a perfect rendition of this area, but you'll recognize this in a second when we get to the spreadsheet. We got to figure out what those z-scores are at 80 and 90. So this guy right here is your 80, and this guy right here is your 90. Now you might remember 90 from before. 90 was that 2/3 that we got when we did the average range, because it went from -2/3 up to +2/3. So that one already had a numerical value at 2/3. Let's see if we can figure out how to generalize the conversion of a raw score to a z-score. So forget 90 for a second. Let's go with 80. How can we figure out what 80 is? Well, I say we look at it exactly the way we looked at, I think it was 120 before or 110, I forget which one we were looking at. Compare it to average. So you're starting at 80, and it's below average. That means it has to be negative. So if you take 80 and subtract 100, you're going to end up with -20, 20 points below. Then you take that distance and divide it by your standard deviation, which in this case is 15, and it tells you how many standard deviations you are below. In this case, you're going to be 1 1/3 standard deviations below. Conveniently, there is a really neat way of encapsulating that. To find a z-score, we've already done this informally for the past couple videos. To find a z-score, just take the raw score, subtract off the average of the distribution, which in this case is 100, and then divide the whole thing by the standard deviation. Now, that's a very wordy way of writing it. Another way of writing it is just z equals raw score, which is x. We'll use that x from a random variable. X minus mu over little sigma. I'm not a huge fan of making this class be about formulas, but that one's going to come in handy. So whatever your raw IQ score is, just subtract the average from it. That'll tell you the distance it is up or down from average. And then dividing it by standard deviations tells you how many standard deviations. So for 80, you would take 80 minus 100 divided by 15. That's -20 over 15, which is -1.33. 333333. It's the same distance as we did earlier, except it's on the other side of average. So instead of being 20 up at 120, it's 20 down at 80. And that's where the negative sign comes in. The negative sign just tells you it's below average. 90 would be done the exact same way, except it would be 90 minus 100, which is negative 10, divided by 15, which is negative 2/3. But we already had that one from before. You were already doing this 2 videos ago. It's just now we can kind of write it as a formula like this, and we can actually use that as we go. So let's go back to the calculator and get ourselves this range. Okay, my friends, so now we're over here and we have our z-scores. I've designed this so it doesn't matter which z-score you put where. You can put either one in either place. So what's the first one we got? We got negative 4/3, and then we had negative 2/3. There we go, and we're still between. There's our area just like we saw before, and we've got a 16% of the graph shaded, meaning 16% of the population falls within the range. What did we just say this was? Below average? Yes, 16% falls in the range below average. Pretty cool. This calculator takes care of all the areas for you.